Hey guys, welcome back from the break. We are now going to embark on chapter 8, lesson 1, which we have fractions, all right? We got old fun fractions that we're going to be working on. Um, Today, make sure as we've always done, these are going to be pages 551 of your new workbook to 556. Make sure that you put your name on the top and you put your one staple right there in the left-hand corner, all right? Now, the essential question for this whole chapter is going to be, how are factors and multiples helpful in solving problems? Okay, factors, not fraction, but how are factors and multiples, how are they helpful? All right. And so we're going to step back a little bit and think about what factors and multiples are. Remember, a multiple of 3, you would say, would be 3, 6, 9, 12, those kinds of things. And then you have factors, you have what are factors of 12? Well, you have 1 and 12. You have 2 and 6, because those are, 2 times 6 equals 12. And then you have 3 and you have 4. Okay, so those are all factors. So we got to remember that when we're working on fractions and division this time. A fraction is a number that names equal parts of a whole or parts of a set. Okay, so it's a portion of something. And the way I always look at fractions, I always think of pizzas. I always think of a pizza. You order this pizza, you have it delivered. There's sometimes 6 to 8 pieces of pizza. You have a whole pizza is one whole pizza. Then you take away a piece. You take away one out of the 8 slices. So that's kind of how I always try to look at it. You can see down here, they have pizzas here. They have these little um, pie charts right here. So you can think of pizza, or you can think of pies as well. But anyway, a fraction represents division of a numerator by a denominator. Okay, and the numerator is on top. Okay, a numerator is on top, and I always try to look at it and say, well, number one, like it's the one on top. So you might want to put that right above on top. Okay, and then you have denominator, and to me it looks kind of like demon in a way. I always think demon, would be the one down below or whatever, but it's kind of a stupid way to look at it. But I just try to remember that, the denominator is on the bottom. Okay. And so these are two numbers, and then you're separated by this little fraction bar right there. And really, all that's saying is this is 1 divided by, because you say right here, 1 divided by 3. All right. So 1 divided by 3. And that's how they get 1 divided by 3. Now, we're usually doing problems where it's like 12 divided by 4, where the big number is being divided by the smaller number. Well, this time the smaller number is being divided by a larger number, which is going to give us, like I said, a fraction of a whole. So on these fractions, we're not going to have a whole number 1. We're going to have a part of a whole. All right. So the numerator is the number of parts represented. The denominator represents the number of parts as a whole. Okay. So try to remember this whole little definition area here, throughout basically this entire chapter. This is part here is going to be very, very important to remember. All right, so math in my world. Number 1, example 1, we have Dylan, Drake, and Jade are sharing 2 small pizzas equally after their lacrosse game. How much pizza does each person get? So they have 2 pizzas, 2 whole pizzas right here, 2 whole pizzas, and they're dividing that amongst 3 people. So that's the 2 divided by the 3. All right. So each person gets 2/3 of a pizza. So 2 divided by 3 is, well, like I said, 2/3. It's the amount of pizza each person gets is between what 2 whole numbers? Well, is this right here. If we had 3/3, that means that'd be a whole, right? But it's not, because you see Dylan right here is getting one piece of that, one piece of that, which is 2 out of the 3 whole pieces. So he's not getting a whole piece of pizza. Or no, he's getting a whole piece of pizza. He's not getting a whole pizza. All right. So that is going to be between 0, between nothing, and between 1. Okay. So the amount of pizza each person gets is between what 2 whole numbers? What, 0 and 1. All right, because 2/3 is not a whole. It'd have to be 3/3 to actually be 1, and we move in this next section. But so again, it's between 0 and 1. And again, yeah, you can see that. Okay. Brownies now. Ray and Bailey are sharing 3 brownies equally. All right, here's your brownies. Ray and Bailey, how many people are there? Well, there's 2 people, right? And they're sharing 3 brownies. Now, this is where uh, we have to think about what we have. We have 3 brownies, and we're sharing these with 2 people. So 3 brownies divided by 2 people. Okay. So that means each person gets, again, 3 divided by 2. It looks like that, right? So if you look at this, 3, they did 3 squares right here. All right, each person gets a whole brownie, and then they take that other brownie and they divide it in half. So it looks like they get a whole brownie and a half of a brownie. So they get 1.5 brownies. So the model at the right shows that each person gets 1 whole brownie. There is 1 brownie remaining, which can be divided equally. So each person gets 1.5 brownies by looking at the picture. So again, 3 divided by 2 equals 1 whole and then a half. So 1.5. So the amount of brownies that each person gets is between this one. Again, you look at it. Well, it's not 0, right? Because that's not even close to being 0, but it is close to 1, and between 1 and 2. Because again, they could have gotten 2. One person might say, "Well, I don't want that other half," but then they shared it equally. So they're going to get between 1 and 2 brownies each time. Guided practice: 2 bags of birdseed. Told you, see. I told you, see, they use birdseed all the time. Are used to fill 3 bird feeders. Okay, 2 bags uh, of birdseed are used to fill 3. So basically, we have these. I don't know how you would draw a bird house. I don't know, like this. I guess I don't know. Okay, and we have to have 3 of those. So I'll draw my horrible pictures, um, and then do my third one here of my birdhouse. So there's my 3 birdhouses, but I have 2. Well, we have bags of birdseed like this, like that. So these 2 bags of birdseed need to fit into these 3 birdhouses. All right. So how much birdseed does each feeder use? Represent the situation using the model. Let's say, 'cause this is the model here, but I kind of just drew it over here also. So each bird feeder uses blank of a bag of birdseed. All right. So we're going to basically split this bag. So we're taking this bag of birdseed, these 2 bags, and we're going to split it up into thirds, right? Because there's 3 houses, so each feeder is going to use blank of a bag. So it's going to use 2/3 of a bag, right? Each feeder is going to use that much. So 2 divided by 3 is actually 2/3. Okay, 2/3. Because again, if we split this up, 1, 2, 3, 1, 2, 3. Okay, each feeder uses 2/3 of a bag of birdseed because again, this is 1/3 and this is 1/3. Yeah, those together you get 2/3. So it's going to use total 1/3 of a bag. All right, or 2/3 of a bag total at the end. All right, let's look at the independent practice here. We have 4. We're going to represent each situation using a model, then solve. 4 families equally share 5 pies. How much pie will each family receive? Okay, 4 families equally share 5 pies. Okay, so what we have is they receive 5 pies and they divide it by 4 families. Okay, so if we were to represent using a model over here, um, you could say, so let's draw it over here. Let's draw 5 pies. So 1 pie, 2 pies, 3 pies, 4 pies, 5 pies. And we have 4 families. So let's just say this is family 1, this is family 2, this is family 3. So they all get a whole pie, right? They all get an entirely whole pie. So that's going to be 1 whole pie they get. Now we got to divide this last pie up here amongst the 4 families. So we divide this pie right here into 4 sections. And then this family gets that. So each of them get 1 out of the 4 of the pie. So each family receives 1 and 1/4 or 1/4 of a pie. So 5 divided by 4 is actually, and they forgot to put it right here, but it's 1 and 1/4 or 5/4 is what they were actually looking for. But and then the answer is between, again, we see that we have this 1 right here. So it's obviously going to be between 1 and it's not 0 because it's 1/4. So it's actually between 1 and 2. Because if you were look at a number line here and you have 1 and 2, well, this is 1.5, right? Well, this is right here would be 1 and 1/4. So that's where that would be. It's between 1 and 2 is how they're getting that answer. 6 bags of soil are used to fill 5 flower pots. Okay. How much soil does each flower pot use, and between what two whole numbers is a lie? So again, if we were to use pictures here, we have 6 bags of soils are used to fill 5 flower pots. So we have, hang on, there's the bell. We have 6 bags of soil, and we're going to divide that into 5 bags or flower pots. Well, if we have our flower pots, which I'm just going to draw a square for these, okay? These are 5 flower pots, right? And we have 6 bags. And, let's draw a circle for a bag. These are 6 bags. This is 1, 2, 3, 4, 5, 6. All right. Then we would have, um, and then we have, well, this whole bag goes into there, and this one goes into there. That one goes into there. The fourth one goes into there. The fifth one goes in there. So these are all taken care of. These are all gone. They all got 1, right? They all got 1 whole bag of soil. And now we have this 6th one that we have to divide up right here. Okay, we have this 6th one that we have to divide up into 5 of them. So what you're going to do is you're going to take this bag right here and you're going to divide it. And I'm not great at drawing these. There's 1, 2, 3, 4. Is that 5? 1, 2, 3, 4, 5. So we divide that up in there. So initially you're going to get, if you shade in one of these, so it's going to be 1 out of the 6 total, or 1 out of the 5 total. So you have 1/5. So you got 1 and 1/5. So 6 divided by 5 is actually 6/5, or it's 1 and 1/5, which is like what we have right here. Okay. So this answer lies between, again, well, if there's a 1, so you got the 1, and then it's getting close. So it's going between 1 and 2 right there, between 1 and 2. 40 yards of fabric are used to make 9 school banners. All right. To use 9 school banners. How many yards of fabric does each banner use? In between what two whole numbers does the answer lie again? Each banner uses, well, again, it says we have 40 yards of fabric are used to make 9 banners. So we have 40, and we're dividing that up amongst 9 banners. Okay. So again, this is kind of like saying 40 divided by 9. Okay. 40, I mean, you could do over here, if you want to do 40 divided by 9, if you know your multiplication, you can say, well, I do know that 9 goes into 40, well, at least 4 whole times, right? Because that's 36. So we can say, well, the whole number is 4. And that way we wouldn't have to draw the pictures like we were doing up here. We could just simply do the division down here, because it's the part you need to understand, that 40 divided by 9 is actually what this says when it's 40. The fraction is 49ths. So we have the 4, and then we have the 4 left over right here. So we have 4, and then we have again the 9 left over. So 4 and 4/9. So 40 divided by 9 is 40/9, or like we said up there, 4 and 4/9. Okay. So this answer is between the whole numbers. Well, we got the 4, and of course we wouldn't go to 3 because it's not anywhere near. It'd be the 5, right? It's between 4 and 5 right there. All right, let's look at the back. Okay, Dermot used 4 gallons of gasoline in 3 days driving to work. Each day he used the same amount of gasoline. How many gallons of gas did he use each day? So he used 4 gallons, and he divided that up over 3 days. Okay. So that's the same as saying, well, 4 divided by 3, right? That's the exact same. Saying 4 over 3 is the same as saying 4 divided by 3. All right. So then you could say, well, he has, well, let's look at it. We have 4 gallons of gas. So I'm just going to say here's a gallon, 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 gallon. And here's our day. We'll put in a square right here. There's 3 days here, right? So we're going to put that one and that one, that one and that one, that one and that one. So each day got 1 whole gallon, right? And now we need to take this whole gallon right here, and let's go over here and divide that gallon up into 3 days, because that's what we need to do, divide it by 3 days. So we draw and makes it look like that. Try to make it as even possible. So then you say, well, 1 day gets that, right? So you get 1 out of the 3 days. So your answer is 1 and 1/3 gallons of gas each day that he used. Suzanne made 2 gallons of punch to be divided equally amongst 10 people. How much punch did each person receive? Okay, so again, you have 2 gallons divided up by 10 people, which is the same as saying 2 over 10. Now, here's the thing with this one. We have, they want you to simplify on this one, okay? Because a lot of you would probably stop and say, well, each person received 2/10 of a gallon. And that's technically not wrong. But I believe we have done simplifying before on these where you divide the top and the bottom by the exact same number. So when you do that, you have 2 over 10. You need to divide the top number and the bottom number by the exact same number to simplify or reduce, okay? And in this sense, we're going to divide both of these by 2. And 2 divided by 2 is 1. 10 divided by 2 is 5. So the answer is actually 1/5 of a gallon is what they got to drink, what they received. All right, and the baseball team is selling 30 loaves of banana bread. Each loaf is sliced and equally divided in 12 storage containers. And if each slice is the same size, how many loaves of banana bread, are there in each container? Between what 2 whole numbers does this lie? So again, we're going to take 30 and we're going to divide this up by 12, or we say 30 divided by 12. All right, and we can come over here and say, well, 30 divided by 12, 12 goes into 30. We do know 2 times, right? So we know that our whole number is going to be 2. We take 2 times 12, we get 24. We subtract that, we're going to get 6, right? When we do the subtraction, we get 6. So we have 6 left over out of 12. We still haven't simplified that as much. So like we did up here in this other one, we have to divide the top and the bottom by the exact same number. So I'm gonna choose to do 6 up here. Okay. So our whole number stays the same. 6 divided by 6 equals 1. 12 divided by 6 equals 2. So each container has 2 1/2 loaves of bread in it. And this answer is between, well, you got the whole number of 2 and, well, 3, between 2 and 3. So each container has between 2 and 3 containers in it each. Okay. You know that if 15 divided by 3 equals 5, then 5 times 3 equals 15. If you know that 7 divided by 8 equals 7/8, what can you conclude about the product of 7/8 and 8? Sorry. The product of 7/8 and 8 is, well, if we have the product, again, we have 7/8 times 8. Well, since we know that 7 divided by 8 equals that with on top of it, okay, um, it'd be fairly easy to see that, well, 7 times 8 would be 56 divided by 8, which equals 7. And that's kind of a weird problem that they jumped into. Um, and we're going to skip this one down here at the bottom. And don't worry too much about this right here because it's a little bit difficult of a problem. But really, it's the main ones up here that we need to learn that 2 divided by 7 is actually 2/7. It's kind of what the the whole lesson is, the whole central question, or how our factors and multiples helpful in solving these problems. So in your guys' problems, again, you're going to do kind of like what we did on the front page, where you're going to take and you're going to look at, well, 3 pounds of potatoes make 8 equal sized servings of potatoes. So you're basically taking 3 divided by 8, all right, and then you're going to write that in the necessary blanks, and you're going to tell me in the end, um, what whole numbers are those between. On the back side with this, looks like a sandwich here, a large submarine sandwich. Again, 1 is divided equally amongst 4 people. All right, 1 sandwich is divided equally amongst 4 people. This is a really easy question, that one. 4 gallons of paint are used to paint 25 chairs. If each chair received the same amount of paint, how many gallons are used to paint each chair? Again, 4 is going to be divided by 25. That's pretty simple. Miss Larson made 12 pillows from 16 yards of fabric. The same fabric. How much fabric was used? So again, you're going to take on this one. You're going to take, excuse me, 16 yards, and you're going to divide that into 12 pillows. All right, so you have like 16 divided by 12 is what you're going to be doing on that one. So that one's not too hard either. This one right here, the vocabulary check, you're going to want to see page 551 to answer that, guys. 551. And then down here, Elena drank 5 bottles of water over 7 volleyball practices. So again, 5, and you divide that up by 7. Well, how does that look whenever you look down here on that one? All right. So when you guys are finished, again, this one, like you said, 4 divided by 25 chairs. You got 4 gallons of paint dividing amongst 25 chairs. So again, how many gallons is that? Write that out the right way. So that should be fairly easy for you. When you guys are finished, make sure again your name is on it and you have a staple in the upper left-hand corner and you have it all finished, and turn it into me in the math box. If you guys got any questions, as always, be sure to see me and ask me a question, and I will be more than happy to help you.